Ugh.
We are live.
All right, so I talked to Marilyn on the phone recently, and she was dropping someone off, and she said she'd be like 10 minutes late, but just to start without her.
Okay.
All right, let's see if we can do this in under 2 hours. We got an hour and a half left.
Sweet.
We're going to do it in less than that.
How about we do it under an hour and a half?
So let's
Yeah,
try and do it in like a half hour.
This one was way easier than last week.
Yeah.
All right.
Okay.
So, you want to lead out, Oslin? What should we start with?
Alright, I'm pulling up the assignment. We'll just go question by question. Does anybody have any questions about the reading this week?
Not at all.
I think what we should do is every time we meet, we should start with, does anybody initially have any questions or not understand something, a topic, and then if they do, we'll go about it. If there is no questions, then we'll just start writing on the assignment.
The only thing that I wasn't totally clear on was random discrete variables. Was that something that you use like standard deviation?
Nope, it's all good.
So the discrete random variable is saying that if that like with randomness, there's no such thing as randomness because everything has a probability of coming back around, right? That's what everybody got, is that when they were saying that when you roll a dice, that the likelihood, everything comes out to mathematically having a 1 in 6 chance of being presented, correct?
Uh-huh. So a random discrete variable is saying, or is that just saying it's just the number? It seems like some hold principle, because like 3.1 in the chapter says finding the mean of a discrete random variable.
Mm-hmm.
So is that just what I was talking about, 3.5? Was that the random discrete variable for the die? Or is that the mean of the random discrete variable?
The mean would be 1. The dice.
The mean would be 1?
Or no, 2.5.
3.5.
Yeah, 3.5.
Okay, yeah, that's the mean. So it's under 3.1 in the chapter saying find the mean of a discrete random variable. So is 3.5 the mean of the discrete random variable? So is the discrete random variable just talking about all probabilities?
Reading it, the phrase discrete random variable has a very specific meaning. A variable is something that varies, of course, and a variable is random if its values follow a specific distribution over the long run. The true meaning of the word discrete is too technical, so it says, roughly speaking, a random variable is discrete if its values could be listed given enough time. That's what the reading says, right?
Okay. So basically that just means any integer within our field of possibilities in our little experiments like rolling a die.
Yeah.
Cool. Okay. Well, that clarifies that. That's my only question.
Okay. So then what we'll do is go back to this. I will stop screen sharing that, and I will screen share this. So then we'll go over part B, part 2.
Wait, we were supposed to do part 2, right? We're going over part 1 with the group?
And the part 2 is what you're supposed to go over the group.
Oh, I thought it said differently this time. Okay.
So as studying the reading assignment, once you complete the questions on part 2, you be sure to take this completed assignment to your group assignment where you can ask and answer questions on this assignment. Oh, so we're supposed to do the whole thing.
Oh. Come.
So, I mean, does anybody have any? If we don't have any questions, if nothing in this assignment popped up to, so what you do is you take you got the variable as x, and the count of the probability that x is going to occur is 1 in 4, which is a 0.25. Then you take the value times the proportion, then that equals the mean, right? So on this number, or this example in the preparation is 2.5, right?
Yes.
Yeah.
And then when you calculate the standard deviation, you take the value minus the mean squared times the probability that it's going to occur, then you get the variance, right?
Yes.
Then the variance, then to get the standard deviation, you take the square root of the variance, and that equals 1.118.
Yep. That's what I got.
Okay. So, well, do we want to just take the quiz?
Yeah, the
I mean,
quiz is
this
actually pretty simple.
This week
I
it
already
was
looked
pretty
at the
easy.
quiz.
Last week was pretty crazy.
Yeah, right. Is there stocks and crap?
Especially when my VMware would not let me connect, so I couldn't even use the SPSS until after we'd already met.
I still can't download it. Like, it won't send me an email to respond to.
Call the help desk. I had the help desk actually over the phone. Then they sent over my work ticket, and of course, right after I hung up with them, it finally connected me with the VMware desktop. And and then they emailed me pretty much almost immediately back, and were going to work with me to try and get it to work.
Okay,
So,
awesome.
yeah, just give them a call or take it up to them. I mean, that could work too. But why don't we just take the quiz then? So I will pull up the quiz. If everybody wants to pull up the Lesson 4 group meeting quiz, we'll take it together.
Okay.
Perfect.
And then we'll find out if we were supposed to.
The quiz is actually super simple. I went through
Oh,
it
did you already
already.
put the quiz
and
on? Oh, you did?
I haven't submitted it. I just want it done. That's all I care about. So it's super simple.
Okay. So, Jocelyn, where are you located at?
I'm at Rexburg.
You're in Rexburg? Okay. So what we do, because oh man, I just got spit up all over. Gross! That was gross. She's laughing at me. I'm in Florida and Maryland is in California. So what works best for us at this moment is doing Tuesday and Thursday at 9:30 my time and 7:30 your guys' time. Does that work for you, or do you have a class?
Yep. Nope, that works perfect.
Okay. It's going to have to change eventually because Maryland is moving to Switzerland in June.
Ah, okay.
So
Okay.
we'll have to figure that out. And because I work full-time as a nurse, so, like, I work today. And so because I'm 2 hours ahead of you guys, by the time I get home from work, it's 9:30 my time.
Okay. I'm really flexible, so.
Okay. So the question number 3. Given all your probability answers as decimal, for example, 0, okay, do not give probability answers as percent. Human blood can be classified into one of 4 basic types, A, B, AB, and O. A proportion of people in the population of the United States with each of these blood types is summarized in the following table. Okay. Use this data to answer the following questions. The blood types and the proportion given in the table are defined above. Define a probability distribution. Be true, right?
That's what I have. I have true.
Yeah.
All adds up to.
It all adds up to
that adds
one.
up to 100%, right? Yeah.
Mhm.
I'm sorry,
So
sorry. Where are you guys right now? You're not on the quiz or the homework or the preparation assignment, or are you?
We're on the
We're on
quiz.
the
Yeah.
group, go to the group
Question
meeting and
three.
start the quiz.
Yeah, I'm on the quiz.
We're on question
Right.
3.
Yeah. Number 3?
Question 3 is about eye color.
No.
Are you
No.
on the wrong quiz?
Are you on lesson 4?
All about probability. Yeah, lesson 4 homework. It's a table with eye color and statistical
If
probability.
you go to the,
No,
are you on the group?
not the
Oh no, that's the homework one. You guys are on the quiz for the group.
Yes.
Yeah, the group meeting.
Oh, capiche.
Did you start the homework quiz?
Yeah.
Well, you might have to complete that because if you exit out of it, won't it close it?
I just open up a new window. Then there's not a timer on it. It should be fine.
There should be
Okay.
like a save for later button too, so you can go back to it.
Oh yeah, that's right. There's a save for later button. So then, what is the probability that randomly selected person in the United States has O blood? That would be 45%. Oh,
Yeah.
2
Just
decimal places.
0.45.
Yeah, 0.45, 0.45. Wait, would it be? It's a 1 in 4.
Yeah.
No, it's a 1 in 4. No.
Because the proportion, they already have it out to our probability.
Oh yeah, there it
At
is.
least
45. That's right. Okay, so it'd be 0.45.
Yep.
What is the probability that a randomly selected person will not have O type? So that would be 0.55,
5.
right?
Yep. Yep.
Okay.
Okay. Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. That's awesome. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. If the dogs guessed at random, what is the probability that they would correctly identify the dish containing the specimen from the bladder cancer patient?
So 1 out of 7.
Yeah.
Yeah.
Which is 14.286. 3 decimal places?
3.
Yeah.
Yeah.
It wouldn't be 14.
0.1214.
Right.
3.
In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? This proves strong evidence that dogs can detect bladder cancer. Right? Because they're saying it is very unlikely that the dog would do this well by random chance alone. So that's saying that the null hypothesis is true, right?
Yeah.
So this is proof. This proves strongly that dogs can detect bladder cancer.
Yeah, so usually it's 0.14, and this is like almost a half. Like 22 out of 54.
Okay. The
I think
M&Ms
so.
are small chocolate. Yeah. The M&Ms are small chocolate candies. The M&M website previously indicated that in the United States, the distribution of the color in a bag of plain M&Ms is given in the following table. And so the green one is blurred out. If you reach in a bag of plain M&Ms, what is the probability of drawing a red colored candy? That'd be 0.13. Why would they give us the answer? Like it's right there. That's it.
Yeah.
I want you to read tables.
Yep. The other assignments were the same way too. They're easy ones.
Okay. Okay.
It's pretty convenient.
I'm like, this is really easy. 0.13. What is the probability that a randomly selected candy is green? So if we have 0.13 plus 0.14 plus 0.13 plus 0.24 plus 0.20 minus 1. So it'd be 0.16.
That's what I got.
Yeah.
All right.
I'm
What
sorry,
is the
what was
probability
it?
that it's not green?
0.84.
Yep.
0.84. Taking the whole
Sorry, what
class
was
like this.
Yeah, Audrey?
Number 9 was 0.16.
0.16?
Yeah.
Mhm. And we did that by adding all of the brown, orange, red, or the brown, orange, red, blue, and yellow probability up, and then subtracted that by 1, and you get 0.16. So that's the remaining 4.
I just missed
And
one of
then
them.
all of
Sorry.
those added up together, 0.84.
Gotcha.
Jocelyn, don't take this personally as I'm muting you.
All good.
What? It's not me. He's muting me?
Jocelyn?
Yeah.
No, I muted Jocelyn.
Oh, I thought you said, oh, this is going to be difficult.
You know what? I can't even stand you giving me the answers. I have to mute you, Oswald.
Well, no, what I was going to say is this is going to be difficult because growing up, I couldn't stand being in class with somebody named Austin or Jocelyn because I always thought they were calling my name.
Ouch.
So y'all can call me Ozzy if you want to make it easier. Last questions. The ACT scores of students admitted to a medium-sized public university in the western United States were taken from CapEx.com. The following summary statistics were calculated. Okay. Use the information from the public university to answer the following. Half of the observation are less than or equal to what number? Half.
24.3?
Okay, so half, that's the quartile. So 50%, the 50% quartile is going to be
Right.
the median, right?
Right. Quartile 2.
Yeah, let me go back. In a box, in the box plot, the 5 number, the minimum, first quartile, second quartile, third quartile, and the maximum. And the you okay?
Yeah, I'm alright.
Are you guys? Sorry.
Is your baby okay? We can't see it.
She's okay.
Okay.
Oh, I'm sorry.
Okay, so half the observations are less than or equal to. So you're saying the median's 24, so
Yeah,
that was like,
the
50
median is the middle number, right?
Yeah, right. Yeah.
So then if the median is 24, right?
Half the observations are less than or equal to 24. That seems right?
Yes, that
Because
is correct.
if the minimum is 14 and the maximum is 35, then the middle number would be 24.
Oh. Okay, so the top 45% of the students scored above 27 then?
Yes, that's correct as well.
Yes, 27. So 11 is 24, and 27 is 12.
Mm-hmm.
Okay. Which of the following statements is not one of the 3 rules of probability?
It's the longest one. It's not C, but it's the longest one.
Actually, in this case, it is.
No, it's
The
that.
probability is high and the probability is positive. The probability is low and the probability is negative.
No, I calculated the
No.
probability. If it's the longest one, it's the right answer by like 80%.
There's no way that a probability can be negative.
Yeah.
So,
Exactly.
that is right.
All right. Does anyone want to push the button?
I got it.
Okay,
You got it.
Jamie.
Remember that. How we do, Jeremy?
Perfect.
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 Submit.
Let's try. 100. Oh, we're so smart. That's 2 quizzes in a
Good
row.
job,
man.
guys.
You know what the probability of that is?
With this group,
1 in a million.
I mean, 13 questions, the 2 quizzes out of 26. I don't even know. Next chapter, maybe I'll do that math.
Okay, so we want to plan on Thursday at 7 or 7:30 your guys' time again?
Sounds good. Hopefully we can
Works for me.
do our
Send
Google
that-
Hangout better.
Yeah. I'm off on Thursday, so it'll give me a chance to figure it out. I think what it is that one person has to start the hangout on air because there's different. Like Jocelyn, when you hung out with me a second ago and with Remington, that was just a plain hangout. I
Okay.
think that you started a hangout on air and you invited me to it.
Yeah.
I think you had done that just a minute ago. So
Yeah.
one person has to start the hangout on air, and they can't get out of it because then it will end the broadcast. Then you invite everybody else to the hangout on air, and then once everybody's there, then you can start the broadcast.
Okay.
I will
Makes
post
sense.
this to my YouTube and post the link to the webpage for everybody, and we'll just plan on Thursday at 7:30 your guys' time.
Sounds good. Thanks, Osmond.
perfect.
All right,
Awesome.
Remington, shoot Marilyn a text and let her know we're done.
Okay, sounds good.
All right, see you guys on Thursday.
All right.
Okay,
have
bye,
a good
guys.
Bye.